right, today we are beginning with 4.64 properties of logarithms. So we're going to develop the first one, then I'm just going to tell you the other two properties. So we're going to begin with m equals the log base b of x and n equals the log base b of y. What I want you to do first is I want you to rewrite each of those into exponential form. All right, pi's, turn to E and tell them the exponential form for the m. And then E's, tell pi your exponential form for n. All right, so you get b to the m equals x, b to the n equals y. What is the answer to a logarithm, everybody? Exponent, right? Okay, the answer to a logarithm is an exponent, okay? So b to the m equals x, b to the n equals y. Now, we want to prove what's called the product property. So if we take x times y, that's going to be b to the m times b to the n. Oh, let's think back. So xy equals b. What do you do to the exponents? You add them, right? So that's b to the m plus n power. Now watch this. This is so cool. I'm going to take the log of both sides. And I'm going to do it base b. Now on the right side, this is where it's going to get interesting. When I have the right side, the log base b of b to the m plus 1, okay, ignore the left side a moment. I'm just trying to evaluate the right side. B to what power is b to the m plus n? M plus n, right? I mean, it really is that simple. So it's m plus n. Now we're going to substitute back in what is m. M was log base b of x, and n was log base b of y. That is the product property, and that's why it's the product property. Let me go back just a moment because I saw some confused faces. On the right side, remember the answer to a log is the exponent on the base. Log base b of b to the m plus n means b to what power is b to the m plus n? It's m plus n. That's the power. So this leads me to my three properties of logarithms. So if I have the log of a product, it equals the log of x plus the log of b. Excuse me, the log of y. And if I have a quotient, I could have gone through and done the same proof, but the log of a quotient, that's x divided by y, becomes the log of x minus the log of y. And then we have the power property that says if I have the log of x to the k power, I can bring the k power down times. All right, we use properties of logarithms to solve equations as well as in calculus to evaluate derivatives and antiderivatives. So these are very, very important properties. If you're going on to pre-calculus, you'll study them in much more depth than what we are, but we're going to just introduce them this year. Whoops, what happened to my screen? There we go. All right, before machines and electronics were adapted to do multiplication, division, and raising a number to a power, Scientists spent long hours doing computations by hand. Early in the 17th century, Scottish mathematician John Napier discovered a method that greatly reduced the time and difficulty of these calculations, using a table of numbers that he named logarithms. As you learned earlier, a common logarithm is an exponent, the power of 10 that equals a number, and you already know how to use the multiplication, division, and power properties of exponents. After inventing logarithms, John Napier designed a device for calculating with logarithms in 1617. Later, they were called Napier's bones. The device used multiplication tables carved on strips of wood or bone. The calculator at left has an entire set of Napier's bones carved on each spindle. All right, so we have much appreciation for John Napier. He made life a whole lot easier. What does the word expand mean? When you think, did you ever do those little sponges and you put them in water? What happened when you did those with the sponges? They got bigger. Okay. To make larger, to make bigger. All right, so here's what I want you to do. Above this, we have some space. And we're going to write these down just because it's going to help us to remember them. If I have log base b of x times y, this equals the log base b of x plus the log base b of y. I need you to, don't copy and paste them. I need you to write them. Okay, it'll help you to remember them. And if I have log base b of x divided by y, this is the log base b of x minus the log base b of y. And the third one, the log base b of x to the k power is equal to k times the log base b of x. So this is the product property, the quotient property, and the power property. So what we're going to do today is we're going to look at expanding. Expanding means going from the right side, going from the left to the right. Do you see that means make it bigger? And then we're going to condense. And the word condense means we're going to start on the right side and move left. And again, we're going to introduce it today, and then we're going to press pause and just work on them tomorrow. So in Roman numeral 1, it says expand. So what does the word expand mean?
Make larger.
Make larger. Okay, we want to make this larger. So this is a product. So this is going to become the log base 4 of 3 plus the log base 4 of x. Letter B, this is a quotient. So I'm going to do the log base 2 of x plus 1 minus the log base 2 of 5. Now I want to pause a moment here to make sure we don't have any misunderstandings, no misconceptions. Is there a property that says log of x plus y equals log of x plus log of y? Do you see that anywhere? On the left side, do you see log of the quantity x plus y anywhere? No. There is no property that says log x plus y equals log x plus log y. Here's what I'd like you to do. If you have your graphing calculators, okay? If you have your graphing calculators, take them out. And here's what I want you to do. Let's do an experiment. And let's just do the LOG button so that we don't need to worry. We'll just use the common log. And I want you to type in log parenthesis 2 plus 3. And then I want you to do log 2 plus log 3. And tell me if they're the same. just use the LOG button, okay? Are you getting the same thing? No. So what I want to make sure we're understanding here is log base 2x plus 1 is not log x plus log 1. That's a big false. It's not true. All right, letter C. Now, what does LOG with no base shown? What's the base? 10. Okay, that's my common log. Remember? LOG means log base 10. It's called the common log. So in letter C, I have log, the quantity 2x plus 1 cubed. I have the power property that says I can bring the power down. And it's 3 times the log of 2x plus 1. Now we just talked about this. Can I split the log of 2x plus 1? No. Okay? We just did that on the board. Log 2. So x is a placeholder for a number, right? So if I can't do log 2 plus 3, I can't split log 2x plus 1. All right, let's try letter E. Oh boy, I really know how to do the alphabet, don't I? Or does yours say D?
No.
Does yours? On mine, I have D, E, F, but up here I have E, F, G. Weird. I think I was cutting and pasting something. Oh, I'm looking at the wrong one. Oh, yeah. Gee whiz, I got to fix that. Okay, so here we go. What if I have a product and a quotient? You have to take care of the quotient first. So watch this. This is going to be natural log 3x to the 4th minus the natural log of y to the 5th. All right, everybody together. When I have natural log, what's the base? E. All right, now I have the natural log of 3 plus the natural log of x to the 4th because I have the natural log of a product minus, and then do you see I can bring my power down? And then I have one more, the natural log of 3 plus 4 natural log of x minus 5 natural log y. All right, so we've just ramped it up quite a bit. So if you have a combination of a product and a quotient, you have to do the quotient first. And some of you are pretty advanced, and if you can notice the patterns, you're welcome to start rolling with it. I can look at them and write my answers without all the steps. But initially, you might want to just do this until you get the hang of it. So I have the natural log of the difference, then this is a product. Why can't I bring the 4 down first? Because look, there's no 4 in front of the natural log of 3. Why can't I do the power rule before the product? You're stumped?
Yeah.
All right, I don't think everybody's stumped. I think somebody's got it. Who's brave enough? Why could I not bring the 4 down? Yeah.
Is it because the 3 is in the exponent?
Good job. The 3 is not within a parenthesis to the 4th power. So that 3 is to the 1st. So I've got to take care of that product. And then I can only bring the power down on the term that it's on. So when I have the natural log of 3x to the 4th, I need to split that as natural log 3 plus natural log x to the 4th. If that had been 3x to the 4th, I would definitely pull the 4 down first. Okay? All right, let's look at letter F. So what I'm going to do first is now you can see a beautiful connection to what we've been doing. What is the square root written as an exponent? 1/2. So that's xy cubed to the 1/2 power. So now I hope you can see the difference between this one and the previous example. Do you see now I must bring the 1/2 down because everything inside is to the 1/2 power. So watch this. This is going to become 1/2 the log base 5 of xy cubed. And expand means you're going to keep expanding until you can't go any further. So now I'm going to have to put a parenthesis or a bracket, and this is going to be log base 5 of x plus log base 5 of y cubed. And then I'm going to get 1/2 log base 5 of x plus 3 log base 5 of y. And now I'm going to distribute the 1/2. All right, letter G. I have the natural log of the cube root of 5x squared y. So, anybody who's starting to get the hang of this, what should we do first? Ideas. Good job. We're going to take the cube root and rewrite that as a power. So knowing that the square root is the 1/2 power, knowing cube root is the 1/3 power is a critical skill. Like, we need to be able to recognize square root is 1/2 power. So now, what's the very first thing I do once I have rewritten this? Good job. You're going to bring the power down. So when you are expanding, you do the power rule first. Let me say that again. When you are expanding, you do, well, as long as it's everything to a big power. That's not true in letter E. I don't do the power first in letter E because it wasn't all to that power. All right, now I'm going to expand the product. But 1/3 is times everything. So I put a bracket. And then I've got a power to take care of. And then I distribute the 1/3. So expanding means to make larger. So this does take some practice. To get the hang of this. All right, so what does the word yeah?
Why wouldn't on F, why wouldn't you put the 1/2 in front of all the other logs? Like you did in the...
I did.
Oh, I didn't see that.
Yeah, sorry. Yeah, it did. It did go across. All right, what does the word condense mean? If expand means make larger, what does condense mean? Yeah, let's make it smaller. All right, so if I want to condense, what I'm going to do is when I have a number out front, I bring the power up. Okay, when you want to condense, start with power property. when you want to condense, start with the power property. So in letter A, that would become log base 4 x cubed minus log base 4 y to the 5th. Well, look back up at your properties, and what do I know if I'm subtracting two logs? Now you're looking at the right side to the left side of the property. Yeah, Brennan? It's the quotient. So this becomes log base 4 x cubed over y to the 5th. All right, letter B. I'm going to start with the power property, and I'm going to make that log base 3 x squared plus log base 3. Now stop and think. If I'm going to take y to the 1/2 power, we usually don't write y to the 1/2 power. How are we going to change that? Square root, right? That's the square root of y. Then look at your properties. Look at the right side. When I have a sum of two logs, what property is that? Look at the list. Look at the right side. When you're adding the two logs, it's the product. So this becomes log base 3 of x squared square root y. All right, letter C. When I have a number out front, this becomes 5 to the 4th. Hopefully we know this one without a calculator. What's 5 to the 4th? Good job, 625. All right, I'm going to pause a moment, and I want you to try D, E, and F. See if you can come up with these on your own. Look at the properties until you get them down.
So when you're condensing, you're going from the right side to the left. And when you expand, you go left side to the right.
All right, letter D. When I bring the power up, that's to the 1/3 power, but we really want to write that as the cube root. Letter E, this is log base 7 x to the 6th plus log base 7 y to the 6th. Then that's a product, x to the 6th, y to the 6th. Now, there's nothing wrong with that as an answer. However, if you notice, is that not xy to the 6th power? Ooh. Pretty cool, pretty nifty there. In letter F, there's a couple different ways you could do this one. We should end up really with the same answer regardless of which way you take this. So if I do this as the log of a over b to the 4th, now I can bring that power up. So you get log a to the 5th, b to the 20th. You should still get the same thing if you distributed first. You'll still get the same final answer. All right, so using properties to expand and condense, this takes a lot of practice and a lot of mental exertion to remember the properties, okay? So I strongly recommend that you do flashcards, you do a Quizlet. If you go Google Quizlet log properties, you'll find them, and then just keep practicing them. You need to do something that makes it stick, okay? Just staying in class, that's not going to be enough. You've got to make some extra effort on this particular topic. All right, Roman numeral 3. Solve 4 to the x equals 128. I'm going to show you a different technique. We've done where you could go from exponential form to logarithmic. And if you like that, you can definitely just stick with that. However, I'm going to show you something. Now that we know our properties, I'm going to show you a different technique. And it's called take the log of both sides. So I just want to show you a different technique, and you can use it or not use it. So on the left side, now that we know the power property, guess what I can do? I can bring the power down and then divide both sides by the natural log of 4. And if I used my calculator, I get 3.5. Well, what I have here is this is actually called the change of base. We have something called the change of base property. And what it says is if I have a log base b of a, I can change it to what your calculate. So back in the day, we didn't have graphing calculators. So we did have a basic scientific would do log, which was base 10, and ln. So what we could do is we could say log base b of a would be ln a divided by ln b, or you could do log a over log b. So that's what we did before graphing calculators. And I'm so old that we used to have log tables and that we didn't have scientific calculators even. And so we had these log tables in the back of our textbook, and we would have to go, and it would go like 4 decimals, and we had to approximate. It was a painful time as a student to do a lot of decimal work. All right, so in Roman numeral 4, all I want you to do is we're not going to evaluate these, but this would be natural log 7 over natural log 2. And here we would say natural log 11 over natural log 9. Now we also use this in AP Calculus.